Okay, today I'm just going to do a few more examples of some different scenarios that can happen. We are going to be using our graphing calculator today. Find the critical numbers of the function. Well, on this one, what we're asked to do is just what we were doing the other day, which is find that first derivative. I don't know what my endpoints are because I have different intervals throughout, so I'm going to have 4 different questions. So we'll just go ahead and find the derivative first, which is just simply -1. This means that there are no places where the tangent line is going to equal 0, which makes sense because our graph would look like the line going down. And so the slopes of the tangent lines to that curve is the same throughout. There are no places where the derivative equals 0 in those cases. So in each one of these, really all I need to do is check their endpoints. So in part A, I'm going to be checking the endpoints of 1 and 4. But on part B, I'm only going to have to check 1. On part C, I only have to check 4. And that is because on both of these last ones, I have open intervals. The parentheses mean the open intervals. So there is no endpoint at 4, and there's no endpoint at 1. And this last one, there are no extrema all the way around because there are no endpoints to check, and there are no places where the derivative equals 0. So I can go ahead and just write my answer as no extrema. Let me show you a quick picture of that just to make sure that you guys are understanding what's going on. At 1, there would be a dot here, and at 4, let's see, it would be at 1. So it would look like this. It's a straight line. There's no places where the tangent line to the curve equals 0, and there are no endpoints, so there are no extrema in that scenario. Going back up to these other ones, I'll go ahead and find what is the y value at 1, which is 4, and what is the y value at 4, that's 1. That means that this is its absolute max, and this one is its absolute min. This one I just plug in 1 and I get 4. Knowing what the picture looks like, I know that this has to be an absolute max rather than an absolute min, and from the prior example. And then when I plug in 4 here, I get 1. So this has to be the absolute minimum of this one, not an absolute max, because I know what the picture looks like. These next ones, we're going to use our graphing calculator, so you may want to pause to go ahead and put these in your graphing calculator. I'm going to go ahead and sketch what is on the graphing calculator so that we can see a picture of what's going on. Let's see. My picture is not going to be exact, okay? It's a parabola going down, and then as it hits, or as it's getting closer and closer to 3, let me redraw that just a little bit. So as it's going down here, as it gets to 3, these do connect. They are continuous, but this one goes off in another direction. So if you look real carefully at your graphing calculator, you will see that there's a slight corner there, or cusp, however you want to define that. And you'd also be able to see that because if you took the derivative here, you'd get -2x. When you plug in 3, you'd get -6 for the derivative at 3. Well, on this one, if you took the derivative, you get -3. So that means the derivative at 3 for this one is -3. Since these two derivatives are not the same value, you know that there has to be a cusp or a corner. So the absolute extreme I can see from the picture would have to be at 1, and it would have to be at 5. But I will mention 3. 3 is just a critical number. It's just a critical number. It doesn't happen to be a max or a min because of the way the graph goes about. It's a critical number because there's a cusp there. The absolute maximum then would be at the value 1, because when I plug 1 in up here, because that's where the interval is part of, I'd get 1. And then my absolute minimum would come from this y, which would be -13. So I'll go ahead and label this as my absolute maximum, and this one as my absolute minimum. And that would be the end of this problem. One more example, we're going to use our graphing calculator again. you guys can go ahead and punch that in your graphing calculator, put me on pause, whatever it takes for you to get that done. I'm going to go ahead and sketch what the graphing calculator will look like. Please make sure that your graphing calculator looks as what my picture does. Otherwise, you're not using your graphing calculator properly, and you need help doing so. What does this look like? Well, it actually has an asymptote at 2. The other part of the graph comes like this over to the right-hand side. I'm not even concerned with this part of the graph because I'm only looking at this interval 0, 2. What we're going to go ahead and do, instead of just figuring out the extrema, is I'm going to show you how you can do this algebraically, and then we're going to use the picture as like a check. So we don't have to have our graphing calculator to be able to do the last two problems, or this problem and the last problem we did. It's just sometimes it's nice to do a check on your calculator. So if I do a derivative, I'm actually going to rewrite this first, so I'm not taking the derivative yet. 2, and then I have 2 minus x to the negative first. Now I'm going to take the derivative. This gives me negative 2. Rewrite the inside to the negative 2. So I lowered that by 1. But I need to take the derivative of what's on the inside, which is a negative 1. So my first derivative ends up being 2 over 2 minus x squared. On top is where the derivative would equal 0. Well, there's no cases for x where the derivative will equal 0. However, on the bottom, if I talk about the x value of 2, it does give me the first derivative at 2 being does not exist. Now I can actually see that in my picture because there's an asymptote there. Of course the derivative does not exist because derivatives do not exist at asymptotes. So what do I have to check? Well, I have to check my endpoints, 0 and 2, as well as my critical number. Well, my critical number happens to be one of my supposedly endpoints. There is no endpoint at 2. We can see that in the picture. It is an asymptote. So when I go to plug in for my y values, and I plug in 0, I get 1 for my height here. And on this one, I get does not exist. There is no value because this is an asymptote. So this is neither a max or a min, but this one happens to be, this would be the absolute minimum. Now, only having the knowledge that we have right now, we haven't gotten further in this chapter, I would have to look at the picture to be able to figure out for sure if that was an absolute max or a min. Later, we'll be able to determine those things using some other skills that we're going to learn throughout this unit.